Okay, PreCalc. This is the evening or the day before your test. And the kind of things we'll be looking at are trig functions that have these changes in them, the A, B, C, and K changes. And you're watching this on Monday after class sometime. So let's review. We had a review sheet in class, so in addition, I'll just mention a few things. So we've said these many times, it's nothing new, just to cement it in your brain so you all do really well tomorrow. So if I have a number here, that's called amplitude. And the amplitude will tell, for example, on a sine curve, it'll tell, say it's a 3. Instead of going up to 1 and down to 1 in 2 pi radians, it'll go up to 3 and down to 3 in 2 pi radians. And that A can be negative, so always watch for this sign, and that will flip this upside down. So the mountain will become a valley, still down to 3, and the valley will become a mountain up to 3. So watch for the sign change for a flip. And when you have a number out here in that position, that is an up-down. It'll move the whole graph, amplitude unchanged, amplitude and all, up and down. So the center line will no longer be here. The line that cuts it in half will be moved up or moved down. And that B is sometimes pretty slippery, so sometimes that B can be over here, so don't let that be an issue. It works the same, it's still an up-down when it appears over here. So, of course, the plus is up and the minus is down. Then we can go left or right. But the left or right kind of change is opposite what it says. So if there's a plus there, you move to the left, and if it's a minus, you move to the right. And that is that change. And the last one is K. The K will squish it up in the horizontal direction or stretch it out, and there's a special key that goes with K. And K is always the actual period of the normal curve divided by the squished period or stretched period, the new one. So K is the number that's sitting right there. And you can find the period by solving for it. All right, so you've heard that a lot. So hopefully it will be with you tomorrow. So you'll be given expressions with numbers in these various places, and you'll be asked to graph them. Then the other direction, you might be given a curve like this, and you're asked to find the equation of it. So here we have a function, and notice if I check on the y-axis, it's a good thing to check there, and I notice it starts at the low point on the y-axis and then goes up. So sine will start here, but cosine usually starts high. But since it starts low, that tells me that I'm dealing with a cosine curve that has been flipped. So right from now, I'm going to put minus cosine theta. And that variable can be an x. It can be anything, but I've been training you with theta and x. Those are our values for x along the x-axis. So we have negative cosine theta, but that's not the end of the story. We see that this function goes down to -3 and up to +3. So therefore, it has an amplitude, always measured from the center line to the highest point, of 3. So that will go in front of the cosine as well, and it'll take the 3 with it there. And the only other thing I should check, I can see it hasn't been moved up or down because the center line is the x-axis, has this been stretched? And the way you can tell is look at the period, and the period there's different ways you can do it, and one way would be from peak to peak, right there, or bottom to bottom down here, or you could look at some crossing point until that crossing point is repeated. Like here's a crossing point going down, and here's a crossing point. So it starts to repeat at this part. So from here to here. Doesn't matter where you look, the period's going to be the same. So I'll take peak to peak. So it looks like if this is 3 pi over 2, this must be the pi mark, and this is pi over 2. This is the minus pi mark. So what's the difference? What's the period? How many radians are between here and here? Well, from here to here is pi, and from here to here is another pi, so it's 2 pi. That is the normal. That is the normal period for the cosine curve, so I do not have a k that I have to stick in right there to adjust for it. So, but you should check, because it might have been squished or stretched in the horizontal direction. So you'll be able to look at a curve and figure out, has it been moved up or down, has it been stretched more than normal or compressed more than normal, and look for amplitude changes, and then has the whole graph been shifted left or right. All right, here's tangent. We don't see a lot with tangent, so I want you to, on the same graph, draw 3 tangent and 1/3 tangent. So we usually start with just a regular tangent. They have the asymptotes, and they appear at negative pi over 2, pi over 2, and then 3 pi over 2, and so on. And the normal sine, no, I'm sorry, the normal tangent has a bend like that, sort of like a snake, and it bends in that direction. When I do 3 tangent, we learned that what that does is stretch it out. So it becomes less of a wobble there, more straight. So that would be 3 tangent. And when it comes to 1/3 tangent, that has more of a wobble. So we come up and we make a little shelf there, and we go around like that. So I'll darken that one. The darkest of all is the 1/3. And of course that repeats all along. Alright, so just a little discussion about the wobbles. And this is less wobble, more straight, and this is more of a wobble. You can set a glass of water right on the 1/3 tangent graph. Alright, let's look at a left-right. Here we have a cosine that's gone. Remember, it's always opposite. This is a right, pi over 4. So I'm going to notice also there's been a k change. So k is 1/3, and 1/3 is going to be 2 pi always divided by the period. I need to know the period so I can graph it. So I can have one mountain and one valley in this many radians. So a cross multiply, I get pi equals equals 6 pi. So I'm just not going to put the regular tick marks in because this has been way stretched. So I'm putting in 6 pi, and that tells me that one mountain and one valley has to be in 6 pi. That's what this tells me, and this tells me I'm going to take that graph and move it to the right, pi over 4. So let me get cosine starts up 1 and goes down to -1. So it's going to be like this. Can you see the one mountain and the one valley? Here's the valley, and this half a mountain and this half a mountain make a whole mountain. Because cosine starts in the middle of a mountain, then the whole valley, and then the other half of the mountain. This is one whole cycle for cosine, and it takes place in 6 pi. And now I'm going to take that and move it pi over 4 to the right. So if this is pi over 4 is just that little bit from here to here. So I'm going to move this over just that little bit. I'm just going to take different spots and move them over a little bit and sketch that. Alright, so I've taken darken that so you can see the final graph is, the lighter graph is to the left, and I've moved the darker graph to the right just a little bit, pi over 4. Alright, that's the kind of issues that you'll be looking at, and I'll check your review from class today. That has everything sort of in one spot, and check the handouts that I've returned to you today, all that work. And I'd like you to do well and make me proud. So see you tomorrow at test time. Till then, good night.